This question is about complexes containing the aluminium ion. Give the electron configuration of Al3+. So there's two ways of doing this. I prefer to do the electron configuration of the whole atom and then take away the last three, because this one will always work even for transition metals. Now, aluminium's not a transition metal, so we could use the other method where we just think how many electrons Al3+ has, but I'm going to do it the way that I first suggested. So aluminium is element number 13. So if we were to put 13 electrons, 1s2, 2s2, 2p6, tracking along the periodic table, 3s2, 3p1. And if it's 3 plus, we're going to lose 3. So 1, 2, 3. And so our electron configuration of Al3 plus be 1s2, 2s2, 2p6. When anhydrous aluminium sulfate is added to water, a solution forms that contains the complex ion, the hexaqualuminium 3 ion. Give an equation for this reaction. So we've taken our aluminium sulfate and we're adding water. We'll need 6 waters to provide those 6 ligands. But we've actually got 2 aluminiums, so thinking about that, we're going to need 12 waters, aren't we? Because we've got to make 2 of these because we've got 2 aluminiums. And when we kick out those sulfates to make way for those, when it dissolves, they become loose in solution, make way for those ligands of water to attach, we would have 3 SO4 2- ions. Balances the 2 3+ ions. Explain why a solution containing AlH2O6 3+ is acidic. So it's all to do with Al3+ is small and highly charged. So it has high charge density. Al3+ is able to polarize H2O molecules weakening OH bonds allowing H+ ions to be donated. The H+ donor we know is an acid. State why the concentration of aluminium sulfate cannot be determined by colorimetry. So Al3+ has no d electrons, so cannot absorb visible light. Therefore, Al3+ is colourless. An excess of aqueous ammonia is added to aluminium 3+ hexaaquat ion. Give an ionic equation and state one observation. So remembering that we've just said that aluminium is acidic, we know that ammonia is a base. We can see that there are 3 pluses. We're going to use 3 ammonias to pull off 3 protons. So 3 of the waters will stay as they are. 3 of the waters will lose a proton. That's an uncharged species, and that's going to precipitate out. Those protons are donated to the base. The base ammonia accepts them to become ammonium ions. So this was acting as an acid. This was acting as a base. The acid donated protons to the base, and we got a white precipitate. An excess of dilute sulfuric acid is added to the products of the reaction in 7.5, identify the species produced. Well, the acids shifts us back to the beginning. Acids are proton donors, so those 3 waters that were deprotonated become reprotonated, and we just go back to the hexaaqua ion. Figure 3 shows the structure of EDTA. Atoms of 2 different elements can form coordinate bonds with the aluminium ion. Draw circles around the atoms of 2 different elements that would link to the aluminium ion by a coordinate bond. So the question is actually only asking us to do the 2 different elements. I'm going to circle all the atoms involved because EDTA is a hexadentate ion. It uses each of these 4 O- ions, so that's one of the atoms involved. You only need to circle one of those 4. The other 2 bonds come from the lone pairs on these nitrogens, so it makes it hexadentate, but you needed to circle one of those 2 nitrogens and one of those 4 O- ions. Hydrated aluminium sulfate is soluble in water. The relative formula mass and X can be found from a titration. Aqueous aluminium 3+ ions react to form a stable complex when treated with EDTA. The excess EDTA can be determined by titration with zinc sulfate. So we're taking our EDTA, which is a lot of it. Some of it reacted with the AlH2O 6,3+, and some of it reacted with the zinc sulfate. So we're going to have to figure out how much reacted with the zinc sulfate and then subtract to figure out how much reacted with the aluminium. 1.036 grams of the hydrated aluminium sulfate. We do need to bear in mind that that would form 2. Remember the equation we wrote back on the previous page would form 2 AlH2O6 3+. Was put into distilled water and made up to 250. So we put, let's draw a diagram, we put 1.036 grams of the hydrated Al2 brackets SO4 3.XH2O into a 250 flask, and then we took that out and we put 25 of that in here, and we added 50 centimeters cubed of 0.0100 moles per decimeter cubed EDTA 4-, but that was too much, remember, it told us that it was an excess. We then took the excess and we titrated it with ZnSO4, and it was 18 centimeters cubed of 0.0105 moles per decimeter cubed ZnSO4, and this was the excess EDTA. So we're going to go step by step. We're going to start with how many moles of ZnSO4 we used. So V times C, 18 centimeters cubed into decimeters cubed times 0.0105 on our calculators. (1.89 times 10⁻⁴ moles. Looking at the equation, the number of moles of EDTA that reacted with ZnSO4, i.e. the excess EDTA, the extra, if we look at the ratio, it's 1:1. That's 1.89 times 10⁻⁴. Now remember what we said at the beginning. Some of our EDTA reacted with ZnSO4 and the rest reacted with the Al3+. So what we need to do now is work out how many moles of EDTA were added at the start. So we go back. 50 centimeters cubed of 0.01, so 50 into decimeters cubed. So 5 times 10 to the minus 4. Okay, so how many moles of EDTA so we put the EDTA in here, 5 times 10 to the minus 4 moles, and by the time we got over here there was only 1.89 times 10 to the minus 4. The difference must be how much reacted with this Al3 plus ions. So EDTA, number of moles of EDTA that were reacted with Al3 plus. We're going to do a subtraction to find out how many. So 3.11 times 10 to the minus 4 moles. That came, remember in the diagram, that is now how many were in here. Okay, we're looking at the ratio of EDTA to Al3 plus is also 1 to 1. So that's the number of moles of Al3 plus in 25. How many, so the number of moles of Al brackets H2O6 3 plus in 25 centimeters cubed equals 3.11 times 10 to the minus 4 moles. So what's the number of moles of Al brackets H2O6 3 plus in the original 250? So we need to times by 10. So we get 3.11 times 10 to the minus 3 moles. Now we need to remember that when our Al2SO4 3 times dot XH2O dissolved into the water, we got 2 of these hexaaqua aluminium 3 plus ions. So to find the number of moles of Al2 brackets SO4 3 dot XH2O, we need to take our answer and divide it by 2. One 1.555 times 10 to the minus 4 moles. So this is the number of moles in that volumetric flask, if we scroll back up, that had 1.036 grams in it. So MR is mass over moles, 1.036 grams divided by the answer. Oops, sorry about that, I've changed the standard form. Divided by the answer on the calculator. So 1.036 divided by answer. And that comes out to be 666.2. Now, way back up here, they told us the MR was 342.3 for the aluminium sulfate part of the hydrated formula. So they told us that this bit was 342.3, and then we've got water 18 times some amount of waters. So 18x equals 324. So divide by 18, x equals 18. So our MR was 666.2 and x equaled 18.